Hello everyone, my name is Akanksha. Welcome to today's session. There are three new trends we are seeing, and I'm going to talk about each one of them in detail. The first trend we are seeing is that there is an explosion of data from all the connected devices. The growth of data is coming from devices like mobile phones, smartwatches, IoT devices, and many more connected devices. Even applications are actually generating data, the social media, the way we are purchasing things. So, mobile phones generate a lot of data. By our own estimate, the volume of data is growing from 10x every 5 years. To take advantage of all of this data, you need to be able to partner with someone who can easily manage this volume of data. The second trend that we're seeing is microservices. Now, microservices are now more popular because application needs have changed. Applications now need to scale quickly to potentially millions of users. They need to have global availability, manage petabytes of data, and responses in milliseconds. Now, microservices allow small groups of developers to build these modern applications and innovate faster, as they can independently build and grow new products for their businesses without bringing the whole application or the website down. And the third trend that we are seeing is there's a transition to DevOps models. Now, businesses are transforming from an IT model to a DevOps model, which gives developer more power to push code to production faster. It also uses automated tools like continuous development, continuous deployment, and continuous integration of new code. So these are like three trends that are driving the new requirement and need for purpose-built databases. Now let's also transition into topic of self-managed databases. Self-managing your database is a tedious, time-consuming, and expensive task. And if you guys have worked on, on databases or worked as a DBAs, and I think you can really correlate to what I'm saying now, is you have to worry about your operational efficiency issues such as hardware and software installation. You need to make sure that your database is fully patched, all the CPU patches are done, make sure the backups are done, and they're done correctly and accurately as well. Performance and availability issues are taken care of, and there could be failures, and failures could be very huge ones, which is like a failure of a primary instance can mean downtime for your application and lost money for your company. In the worst case, a faulty backup plan can result in permanent data loss. Now, many DBAs don't even know how the databases will handle an instance failure until it actually happens. Now, when using an on-premise data center, capacity planning is a regular fact of life. You plan months in advance, guessing at your growth rate, and then you overestimate to be on the safer side. And by doing this, you're wasting money on unused infrastructure. And occasionally, if you're not good in projecting your growth rate or your need, you underestimate it. And then you leave your customers unhappy with unexpected downtime. Now, as a DBA, we really want you to innovate on behalf of your customers and not manage infrastructure. This is like a shared model that we have, but we'll start off with the left-hand side. So if you look at the left-hand column, this is what we actually spoke about just now, where you look after the whole stack, starting from server provisioning, patching, configuration, and recovery. And on the right-hand side is shared model by AWS, which is also like our fully managed database services by AWS. We handle all the fundamental operation. You get the patching, minor upgrades without downtime, automated backup, failover, high availability and durability is taken care of. And we're able to provide you all these features through a console with single click because we're using AWS Cloud. The AWS Cloud is split into different AWS region. Each region is split into multiple availability zone, which which acts like a separate data centers within the region. When you're using managed databases on AWS, your database storage is automatically scaled according to your needs. So you will never have to run out of disk space. Your database instance size or the cluster size can be increased as needed quickly in the console. You have to, we are based on the model, which is like pay as you go model, which is based on you pay only for the instance and storage that you use. This results in more flexibility and obviously less guessing upfront. As a database administrator, you provide value by assisting on schema design, query optimization, and access control, building new applications, and making your customers happy, and not by managing infrastructure. For the new modern architecture, AWS offers 15 purpose-built database engines that support diverse data models that allow you to build use case-driven, highly scalable distributed applications. By picking the best database to solve the specific problem, customer can break away from the concept of one-size-fits-all database and focus on building applications to meet the needs of their business. This allows customers to scale faster, innovate faster, build new features faster. Now let's look at the fully managed database services that we have. We provide a wide variety of database types. Now, if you're using a relational database, then Amazon RDS includes supports for 7 different relational database engines. This could be open source options such as MySQL and PostgreSQL, or a commercial option such as Microsoft SQL Server or Oracle Database. If you're using a non-relational database, AWS offers multiple options there too. AWS DocumentDB is a fully managed MongoDB compatible document database. Amazon Elastic Cache provides support for both Redis and Memcache, and Amazon Keyspace is an Apache Cassandra compatible database with serverless scaling and pricing characteristics. Now let's look into the managed database that we have and how do you move basically to the managed database services. The most straightforward and simple solution for customers who are struggling to maintain their own relational databases at scale is to move to a managed database service like Amazon RDS or Amazon Aurora. In most cases, the customers can migrate workloads and application to a managed service without needing to re-architect their application, and their teams can continue to leverage the same database skill set. Now, some of the customers who migrate to self-managed databases are essentially running the databases on premises. They would like to reduce database burden. They do not want to re-architect, and they would like to have better performance and availability and scalability. Now, the easy way is customer can lift and shift their self-managed databases like Oracle, SQL Server, and PostgreSQL, MariaDB to Amazon RDS. For customer looking for a better performance and availability, they can move their lift and shift their MySQL and Postgres databases to Amazon Aurora and get 3 to 5 times better throughput. Now, Amazon RDS provides, a couple of very nice features. For example, it provides you the scale and performance, and it automates the time-consuming administrative task like provisioning and database setup and patching and the backup. Customers who are using non-relational databases like MongoDB and Redis as document and in-memory databases for use cases such as content management, personalization, mobile application, catalog, real-time, gaming, So the most straightforward and simple solution for these customers who are struggling to maintain their non-relational databases is to move into our fully managed non-relational database services, like moving self-managed Mongo databases to Amazon DocumentDB, moving self-managed in-memory databases like Redis and Elastic Cache to Amazon Elastic Cache. And in most cases, these customers can migrate workloads and applications to a managed service without needing to re-architect their applications, and their team can continue to leverage the databases that they are using. Now, customer wants to move away. This is, I think most of you will also correlate is, you would like to move away from old guard databases because, they are expensive. There's a proprietary, there's a lock-in, they offer punitive licensing and comes in with frequent audits from the vendors, which nobody really likes. So even if you are not using that feature, but if you clicked it, then it will be flagged in the audits and you have to pay for it. So, there's a common trend that we're seeing is customers would like to move away and go into a license-free model where they don't have to pay for any license to any of the vendors. And for that, we have built Amazon Aurora, a MySQL, PostgreSQL compatible relational database built for the cloud that combines the performance and availability of commercial databases while providing the cost effectiveness of open source databases. Now, there are no annual licenses. You pay for the capacity you use. This turns your capital expenditure into operational expenditure and better matches your cost with your revenue. Now, some of the Aurora key features are it is highly durable. Amazon Aurora database volumes are up to 10 GB in segments, and each segment is replicated 6 ways across availability zone. It's highly fault tolerant because it handles the loss of up to 2 out of 6 data copies without losing write availability or 3 out of 6 copies without losing read availability. It monitors your disk and nodes for failure and automatically replaces or repairs them if it finds out anything is not working fine. There's a continuous backup, incremental continuous backup with no impact on database performance. It is obviously designed to be compatible with MySQL and PostgreSQL. So, if you are on any of the commercial database engines and if you would like to go into microservices, this is also the right time to think about, going completely license free and move to any of the cloud native databases that we have, and Amazon Aurora is actually one of them. Now let's look into how is the application landscape changing, right? Now back in 1670s, mainframe was prominent way of building application. This lasted until 80s where the client server was introduced, and then that also significantly changed the way applications were built. And then the internet arrived in 90s, and as a result, the underlying data model also changed predominantly, and database still remained monolithic. But now this has changed. Now we fast forwarded again to today, then you see that microservice architectures are how applications are built in the cloud. Microservices has finally reached the database, and this allows developers to do what they do best. They break large applications into smaller services and pick the right tool for the right job. They want to avoid a single overburdened database with one storage engine and one compute engine trying to handle every single access pattern. Now, there are other things that we have also seen, that latency requirements are much lower and they are expected to be able to handle millions of transactions per second. So in general, the application landscape is changing. And if you look into this, the change requirement of applications, the user growth is also changing, right? So the applications are going global, right? Businesses are capturing more data, as I said earlier. It's like, there's a huge data growth happening. There's a huge emphasis on performance. Businesses don't want to dilute the user experience these days, right? And if you talk about scalability, then a lot of businesses are embarking their digital transformation, and these measures of scales are component by number of devices that access their application. There are billion of smartphones in the world, and mobile is bare minimum expectations in 2021. So all of these requirements are actually changing the application landscape, the user expectations and the requirements around it. And to tackle this, we have provided 15 purpose-built database engines that support diverse data models that allow you to build use case driven applications by picking the best database to solve specific problem, and customer can break free from one size fits all. And if you go from here, then you can see we have relational databases, then we have DocumentDB, we have in-memory cached databases. Let's look at the variety of purpose-built databases that we have. We have key value database, DynamoDB, which stores database as a collection of key value pairs, and it is ideally used for e-commerce, shopping cart, product catalog. The next one we have is DocumentDB that stores data in a JSON or JSON-like document, and it's ideal for mobile applications and cataloging. In-memory databases store databases in memory for low latency access, and they're ideal for caching and gaming. We have graph databases, that represents relationship directly and are ideally used for social networking or fraud detection. Then we have time series databases, that stores data in time order, and append only, which is ideal for DevOps and application monitoring. And last, we have ledger databases that stores in immutable or transmittable cryptographic logs, and it is ideal for finance, manufacturing, HR, payroll, retail invoices that I can think of. So we have a huge broad spectrum of all these purpose-built databases. Now, in the next that I really want to dive deep into DynamoDB. It is a key value and document database that delivers single-digit multi-second performance at any scale. It's a fully managed, multi-region, multi-master database that is built in with security, backup, and restore. And some of the key features or some of the highlights are DynamoDB can handle more than 10 trillion requests per day and can support peaks of more than 20 million requests per second. Oof, okay. So DynamoDB actually automatically scales tables to adjust for capacity and maintains performance with zero administration. Availability and fault tolerance are built in, eliminating the need to architect your application for these availabilities. It encrypts all the data at rest by default. We have point-in-time recovery feature that helps you protect your tables from accidental delete or write operations. DynamoDB is serverless. Also, it integrates with Lambda, AWS Lambda, to provide triggers, and using triggers you can automatically execute a custom function when item level changes are done in the DynamoDB table. So hundreds of thousands of AWS customers have chosen DynamoDB as their key value document database for mobile, web, gaming, IoT, and all applications that need low latency data access at any scale. The next database I would like to talk about is DocumentDB. A wide variety of applications, drivers, and tools that customers already use today with their MongoDB non-relational databases can be used with Amazon DocumentDB with little or no change. It is compatible with MongoDB 3.6, 4.0 drivers and tools, and latest support can be found on our website. But with the launch of the support of MongoDB 4.0 compatibility, Amazon DocumentDB supports the ability to perform asset transaction across customers. Customers can easily migrate their MongoDB databases on-premises or from on-premises to either EC2 or to DocumentDB. DocumentDB is also very much integrated with our Amazon CloudWatch, which provides you metrics for your database instances, and it provides you some very key operational metrics for example, how does your cluster look like, compute, memory storage, throughput. So you can since it is integrated, you can get alerts, you can see the current status of these matrices herein as well. And lastly, it supports 15 database read replicas as well. Now, Database Freedom is an AWS database and analytics modernization incentive focused on accelerating enterprise migrations from Oracle and SQL Server, Netezza, Teradata, Cassandra, or MongoDB platform to AWS Cloud Native Database Services. It is an incentive program, but it not only provides you an expert advice, it provides you workshop, partners, migration assistant to help you with your migrations and guide you through your migrations. Now, we have a series of migration workbooks or playbooks that we call them. They are freely available for download on our website and provides a step-by-step guide outlining how migrating your databases or what you should look out for. These are extraordinarily detailed and can help anyone who's looking to migrate themselves with common technological hurdles or things to watch out for. I also would like to talk about DMS, which is data migration service that we have, and it is used to migrate between homogeneous database types, such as going from one MySQL instance to a new MySQL instance, or you can use DMS to migrate between heterogeneous databases, such as moving from a commercial databases like cloud to a cloud native relational databases like Aurora. There's another great tool that we have, which is a schema conversion tool, and it helps you to migrate your database schema between heterogeneous data types, It attempts to convert all the schema and code objects of the target database engines, including the stored procedures and functions. It also scans and converts your embedded SQL statement in application code. So in combination of Playbook, DMS, SCT, it is very easy to migrate your databases to AWS. Let's look into partners. We have quite a range of partners with us, but the question that I get asked is, why do we need partners? So we really recommend looking into our partners that can help you to do any proof of concept, or actually can do migrations for you as well. They help you reduce your operational cost so that you can focus on innovation as well. So here is quite a few of our partners. We have migration partners. We also have license advisory partner here as well. So if you would like any help on your licenses, or you would like to know more about them, then you can refer any of our partners here to help you with that. And lastly, we have a lot of resources. We have also launched our database certification. So if you guys would like to know more about databases, you can visit the website mentioned here, or you can take the database certification as well. More information, contact us. And then once again, thank you for joining today's session.